talking more about
improper. Oh, thank you. I appreciate it. So yeah, nothing new today. I was going to come in and start on the next section, but then I looked at the web work and realized only a couple folks were done, and Josh was stressing out last time. It took him like 2 hours to do like 2 problems, and so I thought we're doing fine on material. We're quite fine, but it's better to understand things, right? It's definitely better to take our time and make sure that we're on board. So here's a quick little quiz. No karma, no grade. Can you fill in the blanks on that? These are 2 little statements I gave one time long ago called Friday or Wednesday.
Is that a P?
Yep. A. That is a P. These little facts, this will become just a very important fact for us one day. And we're going to start off with some simple problems today just to see how you're doing and how you're feeling about this stuff, nothing complicated. I think that's a good way to spend the day. And then we'll have time to just finish stuff. Really all I care about here is when does it converge and when does it diverge? What value of exponent makes that happen? So does anybody remember on this top one, when does this integral converge? What has to be true about p, the exponent on the bottom?
Smaller than 2, right? No.
No, but that's cool. I appreciate you going for it, Lou. So let me just step in here. It seems like I ought to step in. So converges if p is bigger than 1, and diverges if p is less than or equal to 1. Up here, this one down here converges if p is between 0 and 1. And this one diverges if p is bigger than 1, bigger than or equal to 1. So this is a useful thing to get an intuition about, do I even have an answer at all? So if I gave you, now, and a couple other points. This number down here, we could actually, let's actually change those. This number down here doesn't matter, so I could just put any positive number down here, and up here, I could actually put that here too. The key thing for this one is this infinity at the top, and the one down here is this 0 at the bottom. So up here, we've got something that looks like this. One of these functions that's dying out like that. So that's 1 over x to the p, and we're interested in this area, all the way up to infinity. So it's an infinite region. Down here, we're interested in the flip side. We're interested in this part of that 1 over x to the p curve, this area right here. Doesn't matter what this upper limit is down here, doesn't matter where I stop up here, and it doesn't matter where I start up there. So if I gave you this and said, what about this? 17 to infinity 1 over x cubed dx. Converge, diverge?
Converge.
Converges, because what's p here? P is 3. Yeah, if p is greater than 1, and it is 3 specifically. What about this one? Diverges because p equals 1, right? So it's really important that p is greater than 1. So this one, let's put these up here, converge. This one diverges. This skill is like basically the end of our class. What about that integral? Diverges. What about this one? Converges. What's P? 1/3. You gotta be careful, right? So you convert it to a fraction. I was trying to get tricky there. So it's this. So here we have P equals 1/3. That is less than 1, so this converges. Because it's not going to infinity, it's the left half up by the axis. So we can use this for intuition as well. If I had this integral, now it doesn't quite look like that. Well, excuse me, or bless you, I don't even know, God. Everything, all those things at once. It doesn't exactly look like those over there, but it's kind of like P equals what? Yeah, what would be the P over 2? So it looks like the P equals 2 case over there. How does this relate to this? Which one's bigger? Which one's smaller? Let's say it that way. Which one's smaller? Which way are you pointing, Josh?
The one on the right.
Do you think this one's a smaller one?
So, no, one left, smaller.
Yeah, that's a better
Smaller
answer.
number, yeah.
That's better now, because the bottom's bigger here, right? Oh, would you mind please hitting record for me, Cassie? Make sure I'm on video.
It's recording.
Oh, is it?
Mhm.
Oh, that's right. Boy, it is gonna be, it's Uber, call it Uber day home, for sure. So does everybody see that this one is the smaller fraction? This x is a positive number, right? This is a positive quantity because it's squared, and here you're adding more, so it's getting less. So if this converges, what do you think happens with that one? If this is finite, what do you think about this? This is less than infinity. This is a finite value, so this is as well, because it's less. So this one is bounded by something I understand, so this one converges too. So I can use that to kind of just get an intuition if I wanted. Here's a weird one. What if I had like x? So let's look at that. So now it's super, this really sucks, right? This is a mess. Forgetting about, eventually it's going to be, the problem here is infinity. The problem in all these is the infinity. When x is really big, that plus 3 doesn't matter. Plus 5x plus 2, that shit don't matter. So this thing is in essence kind of like, what p power?
3.
Careful, what's the net p?
2.
2, because it's x, right? So if I divide, it's actually an x squared. So I expect this to converge as well, just because it's like 1 over x squared. Yay! Glad you're here. It's all good. So knowing this result is, rarely are you going to have one of these exactly, but you can understand your problem at hand by kind of thinking of it roughly like this. It's just a guideline. Just a guideline. So let's look at some more problems. Let's start off simple. Can you do this one? Good Lord. Come on. Integral. Oh, yeah. From 2 to infinity, e to the negative x dx. We're going to do a bunch of simpler problems today and make sure that we understand what's happening. Let's start with this one. You won't want to use those first 2 rules. They don't really kick in here. And the answer is what, not just does it converge or diverge, but exactly what is it? I was saying that for this kid, right? What happened?
Just trying to make it to where it actually shows the top of the board.
Oh, is it not working? Oh, thank you.
Yeah.
Thank you.
It was missing like that
You need
corner.
to adjust the pasta.
Coefficient of pasta. Get that picture out for you, Kendra. Stuff, I got it all recorded, Vivian, just the like early part of the class. Let's work together today. Like, you know, ask me questions. Let's talk together. What you got here? That's looking good. Yeah, I think that's a beauty. Oh, absolutely. Oh, I've got you covered. Don't worry. So we will do that. Got a whole little grab bag of integrals. And hopefully you are keeping, every once in a while I'll give you something that I say, you should write this down and have it handy. When I'm working with someone and they don't have it handy, I have to remind them, so I'm reminding you all. This shit happens like 20. This shit happens 24/7 in this class, right? You're gonna have e to some constant power. Let's get the other couple up here. This probably won't happen again because that's just a mess at infinity. But just that whole 1/k coming out in front, that rhythm. These are wonderful things to be speedy at. And that's how I did this one so fast, right? Here k is -1. So just whip it out. Almost not even thinking. Ooh. Sure we're on the right track together. Yeah, good. This doesn't make a sound. It doesn't make a horrible sound, but it actually feels kind of cool to do that. What happens to this as b gets bigger? And as b goes to infinity, what happens to this? I hear it being whispered. Voice is like a horror film. What does it do? It goes to 0. Here's the picture, right? Goes to 0, because that's just 1 over, because e to the -x is 1 over e to the x. You've got something fixed over something that's blowing up, and that's going to go to 0. So remember this, 1 over big is small. Constant over big is small. So the answer here is just e to the negative second. The 2 is what actually gave us our value, right? If this had been a 3, it would have been e to the negative 3. It's just like just looking for little rhythms and patterns there. Is there any questions at all on that problem? Because I want to make Josh happy. Yes, Kendra.
This is more of like a pattern thing, but if it's just e to like any value x, is it going to just, like, if the bounds are some number to infinity, and we're integrating e to some value, will the answer just be that value?
No, it depends. So this one is nice. If it was like this, then things are going to be a little bit different.
Mm-hmm.
So here it just worked out. I didn't mean to imply that there was like
Well,
this
no, I was
quick
just
rule.
curious.
No, it's cool, and I appreciate that you're looking for the rhythm. But like in this one, if this had been here, then this would have been here, right? And then this would have been 2/3, and there'd have been a third in the front. So it gets a little trickier. I don't know that there's any shorthand. Yeah. Good question. Any other questions on this one? Can I erase these so we don't have these like down and ready to access? All right, beautiful. Let's do another one. Yeah. Why not? We just talked about it. This is a little tricky. This is a little weird. This is kind of what you're looking for, right, Josh? Something like this. Let's talk about the rewrite. You're going to replace the lower limit. You can use any letter you want. There's nothing magical about A or B. Thank you, though. So polite. I appreciate it. One of my, Daniela knows exactly what I'm gonna do here. One of my discrete math students put a big plate of fries and ketchup in here, and it stinks. You smell it as ketchup. Oh, I would. There we go. So what does this graph look like? We've got this 3x thing. We should understand the thing we're integrating. What does it look like? Which, does it blow up over here or does it blow up over here, left or right? Right side, yeah? And let's get a couple values. When x equals 0, it's 3 to the 0, which is?
1.
Yes, beautiful. And what happens when I come out this way? Yeah, it tends towards 0, right? Yeah, so it's dying out. And then it blows up on this way. And is this graph going to change a lot? What if I put this here? 103. This is 1 right here. Pretty much same damn graph, no matter what. Right? So this e to something x, as long as that something is positive, it doesn't really matter. They all look like this. It's all the same thing. Like how steep this is, of course that's going to change, the actual values, but the shape does not change. So that is a really important graph to know, because when I come over here, I see that this is fixed. What is this doing as the exponent goes negative? It's going to 0. Does everyone see that? Please see that. Now's the time. So my answer is 1 over 3e to the negative 3, which just, you know, if you like, I just like doing that. You don't, this is fine, that's a beauty. Questions on that? No? Okay, let's try another one. Let's do some more negative infinity stuff. Okay, let's talk about this one instead of me just like sending you loose into the field to run screaming through it, whatever might happen. And maybe it won't, maybe you find a little route there. You're a good tracker. This stuff sometimes shuts people down, right? So I saw the faces on Friday and I remembered them and they scarred me, just the looks of terror. Don't forget that you know how to do this. So if infinity becomes, you know, intimidating, just fucking pitch it. Go back to the heart. If you can do this, then you're halfway there. What is this? Don't look up here, stop. Take off my shirt and horrify everyone. But nobody needs that, nobody needs that.
Partial fraction. Is that arctan?
Arctan? Not yet. We're going to do partial fractions one, but not yet. Arctan. So that is, so if you go to the table, we have this form that says du over a squared plus u squared, that beautiful table I have that I gave you, and that is arctan of u over a. Did I get that right, Josh? Because Josh just looked this one up. Yeah.
I think so, yeah.
Are you? I think this. Can somebody check that out for me? This is the part, the inside part. I'm pretty sure it's u over a. Yes. Thank you. Thank you. So arctan, I've got a equals 1, u is x. Everything's really hunky dory. So it's just that arctan. So this, let's do some rewrites. So first off, like it starts to feel a little less insane, because I've got arctan, and then I gave you this graph. Pi over 2, negative pi over 2. As a person doing science, you should know the arctan graph. Really important graph. It'll show it, not just in calc. This is important stuff in here, but like elsewhere in applications, good graph to know. Why is that good to know? Because now I can do things like this. What is the limit as x goes to positive infinity of arctan? Pi over 2. And what is the limit at negative infinity? Negative pi over 2. Exactly. Let me tweak this up just a little bit. What about this?
negative pi over 2.
It's still the same thing. This inside thing is going at a different rate to negative infinity, but the inside stuff is still going to negative infinity. The key thing is, this part in here is moving left forever. And so this answer is still negative pi over 2, no matter what multiple of x I've got inside there. And that's going to become important in one of your web work problems, where you have a equals 2 maybe, or something like that. So let's do this. Let's do the rewrite now. This is going to be limit as I'm going to use a goes to negative infinity, a to 1, 1 over 1 plus x squared. I'm not even doing the integral yet. Just doing the rewrite to offload to my paper what I don't want to keep in my mind. The reason we have mathematical notation is because it's hard to keep all this stuff in your head. This is bookkeeping. This is technology. So we're using some tech to offload weird things. So now I do this, I carry this along and say, well, I'll save that for later. It's a little bit of fun I get to have. Then this is arctan of x from a to 1. And then that's lim, a goes to negative infinity. Do the arctan. I am going to make you find that arctan. Tell me what that is. That's why I was smiling earlier, getting giggly. Take a moment and simplify this to one single number, which will involve a fraction and 2 actual numbers, but like give me a single value for this. The arctan of 1, you probably either know it or you don't. What angle has a tangent of 1? You could ask the question that way. What special angle has a tangent of 1? Tangent is TOA, opposite over adjacent. That could help. See if I just catch up. What is the answer, anyone? Anybody have it? What you got, Vivian?
3 pi over
3 pi over 4, that is interesting.
4. Or maybe not.
I think you're right. No, that's beautiful. That's actually beautiful. Yeah, it is 3 pi over 4. Yes, you were right. My brain was wrong. So well done. Let's do this. So this part here, this is what I really hope you can get. I'm not, today's not about trying to remember trig stuff. What is that limit? If you know that, then you're doing good. What is the limit as a goes to negative infinity? Vivian already answered it. Negative pi over 2. Indeed, right? Look at the graph. Arctangent is the argument, the thing you're taking arctangent of goes left. Negative pi over 2. So then, and then this, Vivian clearly knew that was pi over 4. Let me tell you how I know that, because I know SOHCAHTOA. I know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So the opposite side and the adjacent side have the same length. That's a 45-degree triangle. So that's 45 degrees, or pi over 4 radians, because we're way past degrees when we're doing calc. Not past, it's just we don't use degrees. So this is pi over 4, and then it's minus minus, so Grace pi over 4. Questions? Reach it. What's next? What's this one? Draw a picture. We could probably answer this from the picture. Today I'm wanting to pull together things for you about all of this. Do we all agree that's a parabola, x squared? Okay, good. Holy shit, like if we can't agree on that, I don't know what to do. Pack it up and just call the semester. So we got this parabola, x squared, y equals x squared. We are finding the area under it above the x-axis from 7 to infinity. That looks like that. Does that look like a finite area? Does it, to be finite and unbounded, you've got to get squeezed. If you are unbounded and you expect to have a finite amount in there, that shit better be squeezing together on the edges. This is unbounded. That is infinite. So I can tell right off the bat that this is divergent. And remember, I don't have to say equals infinity. I just say there's no finite value for that. That's divergent. Let's do it though. I saw everybody diligently cranking out antiderivatives. That's awesome. You can get there the same way. But I want to try to make this stuff pull together for us. So limit as a goes to infinity, 7 to a, x squared dx. That's step 1. Step 2 is do that. Limit as a goes to infinity of 1/3 x cubed. Can I skip some stuff here and say that's 1/3 a cubed minus 1/3 7 cubed? Is that cool? A is getting unboundedly bigger. So its cubed is even worse. This shit's just blowing up. So it's divergent. I could say plus infinity, but really we don't want to. We just want to say divergent, bad integral. Bad. No, it's actually, it's a pretty integral. It's just not doing the kind of stuff we're interested in. Any questions on that, friends? Notice how the picture gave me the answer, right? The picture gave me intuition. Let's do another one. Integral from pi to infinity, sine of 7x dx. function. This is, do we all, like, let's just get together. Gonna be whispering to some folks walking around acting all shifty and shit. How do we feel about this, getting to here? Yeah, we're feeling like, okay, cool. So, this you might be like, oh, he wants us to get the graph out. We could do that, right? But if this doesn't work, it blows everything up. So what does it mean to have a limit at infinity? Can somebody tell us, what does it mean if I say the limit as x goes to infinity of some function is equal to some number? What does that mean? Just like intuitively, what does that mean? What does the picture do? Kendra?
As x gets larger, whatever line you're drawing gets closer to a specific value.
Yeah, so it gets closer and closer to L as I move out this way. So that means that if this is L, I've got like an asymptote almost. So here's y equals L. As I move out this way, and I don't have to do it in the ways that we're used to, it can even be all weird like that, right? But the closer you tell me how close you want to get to L, I'll tell you an x value big enough to get you there. That's what this means. So that's what a limit is. You tell me how close you want to get to this output, I'll tell you an x range from there on out that'll get you as close as you want. So you think about, there's a little tube around this thing. And no matter how tiny I make that tube, you can find some spot from that spot onward, you're inside your little tube. And I say, wait, I'm making the tube smaller around L. And I make it a little smaller, and you're like, that's cool, because the limit exists. So I just have to move out a little bit further to get you inside that tiny tube. That's what that means without getting too technical. Does this cosine function, cosine of 7b, well, who knows, we could get precise about it, but it's still some cosine. Does that settle down? That does not ever settle down on any value. That limit does not exist. For a limit at infinity to exist, you've got to approach a line. You essentially have to look like a line outright. For a limit at negative infinity to exist, you have to look like a line out left. So this does not exist. It never settles down. So the whole thing, I don't even have to do any of this. It's the best trig you could ever hope for because you don't have to do the trig. Does not exist. Divergent. This integral is divergent. Got another one.
Quick question.
Yes, please ask. Yeah, sorry, I should have taken a question.
We did this with sine, and sine does have a value. No?
Nope, limit, so this limit has sine, here's my good ones, right? There. So if I have, sine, let's just look at sine, Kendra. Sine, blah, 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 blah. That never settles down. So this limit, as x goes to infinity of sine of, you pick your favorite multiple besides 0, and that does not exist. However, let me tweak it. Since we're having fun today, we're talking about all this stuff. What about this? What if I said, find the limit as x goes to infinity of sine of x over x? What does sine of x over x look like? Let me help here a little bit. What's the most sine can be?
1.
Beautiful. What's the least it can be, Lou?
-1.
Correct. So this is true, no matter what x is. Top is between -1 and 1. What happens to this as x goes to infinity? Goes to 0. What happens to this as x goes to infinity?
0.
So what must happen to this?
zero.
Zero, it gets crushed. That's called the squeeze theorem. It gets crushed to zero. You sketch out the graph of this, it looks like this. It looks like, it starts at 1, which is, you might be like, what the hell, but it looks like a spring losing energy. It's like a mass spring just losing energy and falling to equilibrium. So this thing actually does have a limit, and it's 0. But that's only because of this underneath, Kitra. Yeah.
Okay.
Yes.
So is that like saying it's like something fixed over?
Yeah, it really is. It's like, yeah, that's a great way to think of it, Olivia. There's like something fixed over X. Yeah. And here I would say it's something bounded. Yeah. Nice. Other questions? This is good. Let's do one together that I would never make you do on your own. God, I hope I didn't. I don't think there's one like this. I was very careful about what I picked for web work. What about this? Integral from 1 to infinity of 1 over x plus 1 times x plus 2 dx. Let's stop for a second. So the first thing, I just want you to look at this without doing any computations. Does that converge or diverge? Think to yourself, what is it like? What is it like? And then answer that question, because you know stuff about P, when P is such and such. That's what I'm thinking about. Look at that. If you sketch it out, it's going to look like this. It's going to die out, but does it die out fast enough? Which of these is it like? What do you think, Kelly?
Well, wouldn't it converge, because you could assume that it's 1 over x squared.
Yes, beautiful. So you see, it's like 1 over x squared, right? Just a little tweak away from 1 over x squared. And if you multiply out this bottom, it's just that, and it's like an x squared plus some garbage that doesn't matter at infinity. So when I look at this, I expect that to make sense and be finite and work. Now let's go back to something Lou said earlier. When I had x squared plus 1, Lou suggested using partial fractions. Couldn't do it there, but I sure can do it here. Let's do the partial fractions. We're going to do this integral because it's in my graph bag. So this is a over x plus 1 plus b over x plus 2. My setup, that's my setup. I'm going to flatten it by multiplying through by the denominator. And I think we've all gotten better at this over the last few weeks. What are some great x values?
-2.
And, yeah,
-1.
-2 and -1, awesome. So I pick x equals -2, dead, -b. So b is -1. X equals -1, dead. A equals 1. That shit's easy. So this actually turns into, oh gosh, this isn't going to show up on my video. Oh my God, that is so good. So this is what we're doing now. We're doing 1 over x plus 1 minus 1 over x plus 2 dx. Let's do this, let's go through. All right, so let's convert the limit. So limit as b goes to infinity, integral 1 to b, and then I've got this stuff here. What do these do? What form are they? Natural log form, yeah, exactly. These are perfect logs with u equals the denominator, and then du is just dx. Can you see that? If u is x plus 1, du is dx, and if u is x plus 2, du is dx. So there's no conversion factors needed. this turns into limit as b goes to infinity. I'm gonna hold off on my limits. Oh wait, hold on, so that's just natural log of x plus 1 minus natural log of x plus 2. And I'm gonna do that from 1 to b. Let me stop, and maybe I'm going too fast, I'm not sure. Just wanna make sure everybody's on board. Yeah, see, no, that's cool. Okay, so let's plug in the limits. So we're gonna get limit as b goes to infinity, and then I'm gonna use parentheses, natural log of b plus 1 minus natural log of b plus 2. That's just putting in the b's, and then minus, in parentheses, natural log of 2 minus natural log of 3. That's when I plug in the 1. So now I brought this in so we could talk about this, because we haven't yet. And it's not in your web work, but I wanted to talk about it. What happens to natural log? What is this limit right here? B is getting bigger and bigger. What's the natural log doing? What does natural log look like? What's happening to that as I move out this way? Where's this go? Goes to infinity, yeah. Natural log of something big is big, and it keeps getting bigger as I move out over. So this is going to infinity, and then this is going to infinity, and that you might think was 0, but you'd be wrong. That's an indeterminate form. We don't know, that could be anything. Let me prove it to you. Here's a limit, here's x plus 2, and then here's minus x plus 1. If I'm doing the limit as x goes to infinity, minus infinity, so, but maybe I should have simplified first, right? What does it actually simplify to? Close. The x's cancel, what am I left with? 1. That's the actual answer, 1. And I could make it 2 if I want. So infinity minus infinity can be just about anything we want by rigging things. So infinity minus infinity is not a limit you can do. You have to convert it into a fraction to L'Hopital that shit. Limits at infinity almost always need to be fractions to understand what's happening. So I'm going to convert this into a fraction. This is the limit as b goes to infinity. Oh my God, I'm using log properties. So the natural log of something minus the natural log of something else is what? Natural log of the what's?
That divided by that.
Beautiful. Natural log of the ratio. So that's what I'm going to do here. So this is natural log of b plus 1 over b plus 2. That's way better. And then this is still minus, what could I rewrite that as?
2/3.
2/3, beautiful. All right, now we're getting somewhere. Now I got a fraction, I can do that limit. What is this inside going to as b goes to infinity? What is b plus 1 over b plus 2 tend to as b gets larger and larger? What's the top going to? Yep, and what's the bottom going to? Awesome. Do we have a rule by some French seeming dude?
Is it 1?
It is 1, yeah, so we could it's 1. We could L'Hopital this shit and get 1 over 1. Or we could realize, look, when b is really big, when b is 1,000,000, what is 1,000,001 over 1,000,002? Freaking 1, right? There's 1 enough for me. And it's getting more 1 the bigger b gets. I also gave you this rule. Remember back, obviously we don't remember, so let's talk about it. If I have the limit as x goes to infinity of a ratio of polynomials, doesn't matter that it's x or q or the s or t or b or whatever in there. This is equal to the ratio of the leading coefficients if they're the same degree. If same degree. And I wrote this out a little nicer last time. It's equal to 0 if the degree of the top is less than the degree of the bottom. And it's equal to plus or minus infinity. You gotta figure that shit out, but if degree of p is greater than the degree of q. So here, they're the same degree, so like Olivia said, and I think that was Olivia, right?
Mhm.
Yeah, so this just goes to 1. What's natural log of 1?
0.
Thank you. Oh God, that was so quick. That's great. I don't have to lay on this filthy floor and wait. So this goes to 1, so this is natural log of 1, and that's 0. So the final answer is negative natural log of 2/3. Doesn't that seem strange? Is that a negative number? It looks negative, but is it negative? Because it seems like that's, like, if you graph those out, that's all like positive stuff. Like if I graph out 1 over x plus 1, x plus 2, it looks just like this. Why does my answer look negative? How can that be? Is math wrong? And just another reason to call it a day and never come back? We broke it? What does natural log look like? There's 1, right? What's natural log of a number between 0 and 1? Negative. So this is positive, even though it looks negative. I just wanted to point that out, because it's one of those kind of days where we're talking about everything under the sun. Yes, ma'am?
Say that again.
Natural log of 2/3 is a negative number. 2/3 is in here. And so the negative out front makes it a positive net effect.
Okay.
Sure? Cool. Good. Thanks for carrying what's under the sun, Vivian. That makes me happy. That's enough. If you're done with your web work, you're done for today. Do as you see fit. If you're not done with your web work, you're staying right here with me to finish the goddamn web work. Wait, say that again? No, why? What's up? A midterm? Is it gonna be in a week? Hell no. They're roughly about a month apart. So yeah. You don't want to leave and then find out it's like on next Wednesday or something. No, it'll be the next exam. Vivian was asking when the next exam might be. It's certainly not this week. That would be bad. It's certainly not next week.
The week after?
I highly doubt that as well. So I feel like 3 weeks.
First
3 to
week of
4
November.
weeks. 3 to 4 weeks out.
November.
Well, after,
That's
November.
what I'm hearing.
November.
after this week, we're halfway done.
I know. It's weird. Yeah, it's great too. Fall break. Hell yes. All right, I'm gonna hang out here and help folks. If you just feel free to leave if you want to leave, because you don't need to do web work. I won't check. Let's see what's going on.
Thank you.
Thank you. Bye.
Thank you.
Bye. Thanks.
See you later.
See ya.
Dr. T, you want me to keep this on or
Yes.
turn it off?
Oh, thank you. Yeah, Cassie, that'd be great. Thank you.